Okay, so today we're doing a deep dive into something really cool. It's all about LLMs,
Okay.
those large language models everyone's talking about. They can write poems or code or even answer your questions like a real person. But here's the thing. How good are they at actually thinking logically? Can they really reason through a problem the way we do?
Yeah, that's the big question. Researchers are trying to figure out LLMs are already really good at spotting patterns in language and mimicking how we use it. But when it comes to that next level of reasoning, actually applying logic in complex situations, that's where things get a little tricky.
And that's exactly what you've been looking into, right? You even sent us this research paper about a new method called logic of thought. LOT for short. It sounds like something out of a sci-fi movie.
It's definitely a fascinating area of research. And the exciting part is that LOT builds on this existing method called chain of thought prompting, or COTI.
Right, like giving an LLM a step-by-step guide to solve a problem so we can see how it's thinking.
Exactly. But while COTI showed some promise, there's a bit of a catch. Imagine you're following a recipe perfectly, every ingredient measured out, but then in the last step, you decide to sprinkle dirt on top.
Now that's just bad cooking.
Exactly. And that's kind of what can happen with COTI. It might generate this seemingly logical chain of thought, but then jump to a conclusion that doesn't actually make sense based on the steps it took part. Researchers call this unfaithful reasoning, and it's a major hurdle in making LLMs truly reliable.
Okay, so then logic of thought comes in, like an upgrade to get LLMs to feel more like humans. So how does it actually work?
Well, this is where things get really clever. Instead of just relying on chains of thought, Lottie uses something called propositional logic. It's a way to represent information and relationships using symbols and logical rules. Think of it like this. You tell an LLM, if it's raining, then the ground is wet.
Okay.
Lot lets the LLM break that statement down into its logical parts. It's raining is one proposition, the ground is wet is another. And then it understands the relationship between them. If the first one is true, the second one has to be true as well.
So it's not just about understanding the words, but the logic behind them.
Exactly. And this ability to really grasp those logical relationships is what makes Lottie so unique.
Now, the research paper breaks down LOT into three main phases. Let's break those down for our listeners, too. First up, logic extraction. What's going on in this phase?
Think of it like giving an LLM a detective's case file. In the logic extraction phase, the LLM acts like a detective, carefully going through the text to find those key pieces of information, those propositions, and the logical connections between them.
So it's looking for those aha moments, those crucial connections that might not be directly stated but are implied by the information.
Exactly. It goes beyond just understanding the words on the page to uncovering the deeper logical structure of the information.
This is already blowing my mind, and we're just getting started. Once our LLM detective has gathered all those clues, what happens next?
That's where the second phase comes in, logic extension. Now that the LLM has those core propositions and their relationships, it starts connecting the dots to create new logical statements.
So it's like our LLM detective is taking the clues from the case file and using them to generate new leads, new avenues to investigate.
Precisely. The LLM uses its grasp of logical rules to extrapolate from the initial information, drawing out conclusions that might not have been obvious at first glance.
Incredible. But we're still in this kind of abstract world of logic and symbols. How does the LLM actually use all this new information? That's where the third phase kicks in, right?
You got it. The third phase is logic translation. The LLM takes all those logical statements it's created and translates them back into natural human-readable language. This gives the LLM additional context, those aha moments to consider as it tackles the original task. It's like the LLM is adding helpful notes to its case file, making the implicit explicit.
So instead of throwing the LLM into the deep end with a complicated problem, Lottie provides a more structured approach. It's like building a logical scaffold to support its thinking, guiding it towards more accurate and reliable conclusions.
That's a great way to put it. And what's even more exciting is that this isn't just theoretical. The research actually shows that LOT delivers on its promise.
I'm on the edge of my seat. Tell me, did LOT actually work? Did it make LLMs better at logical thinking? Let's find out right after this.
It did. The research team actually put LOT to the test, and the results were pretty amazing. They ran these experiments across 5 different logical reasoning data sets. Basically, think of them as specialized logic puzzles for LLMs, and then they compared how LLMs did with LOT versus just using standard prompting methods.
So it's like a logic Olympics for LLMs. What were the events?
Exactly, and LOT was consistently taking home the gold, for instance, on the Reckler dataset. which focuses on deductive reasoning. You know, like that classic, all men are mortal, Socrates is a man, therefore.
Right.
LOT actually boosted accuracy by up to 4.35%.
4.35% might not sound like a lot, but in this field, even tiny improvements are a big deal. Right? What kind of real-world impact are we talking about with that kind of boost?
Oh, you're absolutely right. Those few percentage points can make a huge difference. Think about applying this to something like medical diagnoses. That 4.35% increase in accuracy could mean catching a disease early enough for effective treatment. It could even be the difference between life and death.
Wow, that really puts it into perspective.
Oh,
So
yeah.
it's not just about LLMs solving puzzles better, it's about potentially transforming entire fields.
Hmm.
What about the other data sets? Did LOT show the same kind of potential there?
It did. Take the proofwriter dataset, for example. This one is designed to test those more complex multi-step reasoning abilities. And LOT's really excelled here, helping LLMs find the right answers way more often than those standard methods.
It's like giving these LLMs a serious cognitive upgrade. But I understand the research didn't stop there. They also compared LOT to another approach called SAT-LM.
Right.
So what's the deal with SAT-LM?
So SAT-LM takes a neurosymbolic approach. It tries to combine the strengths of neural networks like our LLMs with symbolic reasoning, which is more like how traditional computers understand logic.
Sounds like a powerful combination.
It definitely has potential. But there are some challenges. One big one is this risk of information loss. Imagine playing a game of telephone. As the message gets passed around, it often gets distorted. A similar thing can happen with SAT-LM. When you're converting natural language into those logical symbols, some of the important details can get lost in translation.
And that can lead to the wrong conclusions.
Also,
Kind of like misinterpreting a clue in a detective novel.
exactly. And this is where LOT has a real edge. Remember how LOT holds on to that original natural language context throughout the entire process?
Right. It's like LOT has this safety net to make sure those important nuances don't disappear.
Precisely. That's what the researchers discovered. LOT consistently outperforms SAT-LM, which suggests it's less prone to those costly information loss errors.
This is all so fascinating. You mentioned earlier that LOT can actually be combined with other prompting methods too, not just COTI. What happens when you combine those powers?
That's another really exciting area the researchers explored. They found that LOT can actually supercharge other prompting techniques, like self-consistency, often called SE, and even the more intricate tree of thought prompting, or TOTI.
Okay, hold on a second. SC and 2T sound pretty complicated.
Let me break those down for you. Imagine asking an LLM a question a bunch of times, but phrasing it a little differently. Each time, SC is kind of like gathering all the answers and then having a vote. The most frequent response is considered the most likely correct answer. It's a way to boost confidence and accuracy by looking at multiple perspectives.
Ah, so it's like the wisdom of the crowd applied to LLMs.
Exactly. Now, TOTI is a bit more involved. Instead of just a straight line of thought, it encourages the LM to explore different lines of reasoning, branching out like a tree. This lets the LM consider various possibilities and even backtrack if it hits a dead end.
So the LLM is basically navigating a maze, trying different paths until it finds its way out.
Perfect analogy. And what's really impressive is that Lottie actually improved the performance of both SC and 2T.
It sounds as no matter how you approach the problem, LOT is there to give those LLMs a boost in logic.
That's what the research suggests. It's like we're seeing the development of LLMs that can go beyond just repeating information and actually start to reason through problems more like humans do.
Which leads us to the big question. What does this all mean for the future of LLMs? Are we on the brink of artificial intelligence that can actually think for itself?
Well, while these findings are incredibly exciting, it's important to remember that LOT is still in its very early stages.
So LOT seems really promising, but like any good mystery, there's always more to uncover. What are some of the limitations the research pointed out?
Well, one thing is that right now, LOT works with a pretty limited set of logical rules. It's kind of like having a toolbox with only a hammer and a screwdriver. You can fix some things, but for more complex stuff, you need more tools, right?
So to really unleash the full power of Lottie, we need to give it a wider range of logical tools, expand its horizons.
Exactly. And that's what current research is focusing on. Finding ways to bring in those more advanced logical concepts and rules into LOT's framework. This could lead to LLMs that can handle even more sophisticated reasoning and solve problems that seem impossible today.
It's amazing to think about the possibilities, LLMs that could analyze legal documents or come up with scientific theories or even help us understand how our own brains work. But before we get too far ahead of ourselves, you mentioned there are still some challenges. especially in that logic extraction phase.
Right. Even though LLMs are really good at understanding language now, they're not perfect detectives just yet. Sometimes they misunderstand the information or miss those small but important connections, or even make up relationships that aren't really there.
So our LMA detective might jump to conclusions or misread a clue or even chase after something that's totally irrelevant. Sounds like we need to sharpen those detective skills.
Exactly. And that's a big focus for researchers right now, trying to make that logic extraction process more robust and reliable. It's like giving our LLM detective a better magnifying glass to help them spot even the tiniest details and avoid those false leads.
I love that analogy. As Lottie continues to develop and evolve, it feels like we could be on the verge of something truly revolutionary. What kind of future could this create? Not just in those specialized areas, but in our everyday lives.
Imagine a world where LLMs are like trusted partners in helping us solve problems. Let's say you need to plan a big move across the country. An LLM with Lati could look at all the factors, your budget, the logistics, even your personal preferences, to come up with the most efficient and enjoyable plan. Or maybe you're having trouble understanding a complicated medical diagnosis. A Lati-enhanced LLM could translate those technical terms into plain language, so you're empowered to make informed decisions about your health.
It would be like having a team of brilliant logical thinkers right at our fingertips, ready to tackle any problem we throw at them. So for our listeners out there, if they only remember one thing from our deep dive into lots, what should it be?
I think the key takeaway is this. We're not just talking about small improvements in AI. LOT is a fundamental shift in how we approach machine learning and reasoning. It hints at a future where machines don't just imitate human language, but actually grasp the core principles of logic itself.
And that, my friends, is a future worth getting excited about. But here's a final thought for you to ponder. If LLMs could reason perfectly, without making a single logical mistake, what amazing things could we accomplish? What problems could we solve? What new frontiers could we explore? The possibilities are truly endless. Thanks for joining us on this exciting journey into the future of logic and language.